Hey everyone, in today's video, I walk you through how to take a 3D scan from a LiDAR scanner and turn it into a CAD model. Alright, let's talk gear and budget, what you will need and how much it will set you back to do scan to BIM. First off, you will need a LiDAR scanner, a solid one that keeps drift low and gives you a clean, thin wall of point clouds. Having RTK support is also a big plus if you need to tie your scan back to a georeference. For SHARE S20 comes in at about $4,999 but if you don't need RTK, the SHARE C1 is a more budget-friendly option at around $3,599. Even with a LiDAR scanner and its bundled software, you won't be able to create a full building model. To make that happen, you will need a professional CAD tool that can handle point clouds efficiently. My recommendation is BricsCAD BIM. It's loaded with the features you need to quickly turn the scan into CAD models, and it offers one of the most affordable perpetual licenses. In the US, BricsCAD BIM is priced at about $2,616, which is a bit of CAD know-how, which I will be teaching you in this video. You'll be able to create a proper 3D model output file that you can deliver to your customers. Altogether, the minimum setup comes to about $6,215, and yeah, that does sound like a lot. Here's the payoff. For a small scan to BIM project under 100 square meters, you can start at around $150 to $200 plus an extra $1 or $2 per square meter for anything beyond that. On a medium-sized job, say 3,000 square meters, you are looking at more than $3,000 for about 2 days of work, including the CAD modeling. With just 2 medium-sized projects, you could cover the cost of your gear and software in under a week. That means your return on investment is really fast. Back before LiDAR scanners, when I wanted to renovate this old apartment, I had to measure everything with a tape. It took hours, and I would still end up going back to remeasure missing dimensions. Even then, the data was low in detail and not very accurate. When you rely on a measuring tape, problems show up later, like when installing a pre-made furniture. If the walls aren't perfectly perpendicular, the pieces won't fit, and that leads to headaches and costly rework. Fast forward to today in the same apartment. This is SHARE S20 LiDAR scanner, and I walk you through the process of scanning the space. This apartment is pretty small, about 75 square meters, narrow, and full of obstructions. You will run into projects like this quite often. This corridor is only about a meter wide, so don't try turning around. Just walk back in reverse once you reach the end. This bathroom is too small to step into, so don't try. Just squat down to capture the floor area. You get enough data to rebuild it accurately in CAD. Watch how I move through narrow space. I avoid making sharp turns and keep my path smooth. Try sliding the curtain so it sits in the middle of the window. Right now it's covering the frame, and the LiDAR can't get a clear lead on how wide the window actually is. When you are going through a narrow doorway, make sure the scanner is pointed toward the bigger space. In this case, I would actually need to walk in backward to keep it facing the right way. Mirrors can cause ghosting in your scan, but I'm not going to bother covering them. You'll be able to tell which parts are ghosted and which ones are the real surfaces. When you are standing, the scanner picks up the floor about 2.8 meters away. If you want to detect a floor closer to you, squat down instead. Just don't tilt the scanner. Doing that will throw off its function. Scanning tight space like this is usually a pain with most LiDAR scanners, but with the SHARE S20 it's effortless. You will notice later that the wall lines stay perfectly parallel with no drifting at all. If your LiDAR can't handle this kind of scan, you end up doing it room by room and then stitching everything together. For a project of this size, scanning and preparing drawings for the renovation permit should bring in at least $500 US. The whole 3D scan only takes about 4 minutes. Here is the process point cloud from the scanner. In CloudCompare, I crop out the ghosting caused by the mirror reflection. Next, align the floor and level it along both the X and Y axis. And here is the scan result. The color pixels still line up sharply. That's how I can tell the LiDAR scan quality is solid. Next, I will raise the floor by 1.17 meters so it lines up with the origin point. In BricsCAD, I start by importing the point cloud. It's also available for you to download. The links is in the description. I drew a straight line along this side of the wall, then added another horizontal line, and you can see they don't quite match up. So I use the align command to match the point cloud to this horizontal line by selecting two reference points. Next, I trace the boundary walls. For the sketch, I will use tools like line, trim, extend, joint, and explode. The point cloud is in meters, so I need to scale it by 1000 to work in millimeters. But if you prefer to work in meters, there is no need to scale. In BricsCAD, when tracing the internal walls, just ignore the openings. We will cut those out later using the push-pull command. The main wall thickness is 100 millimeters, but in certain areas like the bathroom or around the kitchen sinks, the walls are thicker. I have already made a video on basic modeling in BricsCAD, so I won't go into all the details here. I made this tutorial so you can follow my workflow and try modeling it yourself from the point cloud. Before deciding to buy a LiDAR scanner, the first thing you should do is get a point cloud sample and test whether you can reverse model from it. These scanners are expensive, so it has to work for you. You need to crop the point cloud at different heights. This gives the clearest view of the wall location. Next, I will create a solid box that is larger than the wall area. Since the push-pull command needs a solid to work, I will use it to pull the walls up. With push-pull, you don't need to join the sketch, which makes it super fast to pull up all the walls. Now that I have pulled up the wall, I don't need the solid box anymore, so I will cut it out. Next, I'm going to create the floor slab as a separate body using polylines. In BIM, you need to specify the type of 3D elements you are creating, whether it's a slab, wall, or columns. So each element has to be a separate entity. Now I'm drawing a rectangle on the wall face to cut out the opening. Sometimes I will use dynamic UCS, and other times I will set the UCS directly onto a face. You can experiment on your own to find which method gives you the fastest modeling. Okay, here's one of my favorite tools is slice plane. When you are modeling a large building, you will end up using the slide plane tool a lot. This sliding door opening is covered by a curtain, so I have to approximate the location of the door frame. So whenever you come across a curtain, just tie it at the center of the windows. The door on the far left is custom made, while the two on the right are standard doors, each 800mm wide. You can see the scanner's precision from the height of the door frames. They are all perfectly aligned at the same level. If you are an architect, I believe you can download the BricsCAD free trial and start working on this right away. It follows the same AutoCAD style workflow, but with more powerful modeling tools, especially the ability to open large point cloud files directly. Here again, I'm making use of the slice tool. It slices both solids and point clouds, so you don't always have to crop them manually. I also have to estimate the width of this window since the curtain blocks it. Next, I'm going to create a handrail using the library structural profiles. In the BIM workbench, there is a tool for building structural frames, not as advanced as Autodesk Inventor, but it gets the job done. Now I'm going to create the drop levels on the floors. There are two spots, one on the balcony and one in the bathroom. When you switch to X-ray mode, you can clearly see the floor levels. This apartment model is very basic. In the future, I bring in more challenging examples for you to practice. But first you should get comfortable creating this model. And here I'm adding the rainwater pipe. Now it's time to create the ceiling panel. I draw polylines along the top of the wall, and the ceiling has to be a separate entity from the wall. I'm going to place the downlight each with a 200mm diameter. You can also mark the positions of the light switches and wall outlets. Just pull them slightly from the wall and they will show up clearly in the 2D drawings. To design a renovation for an apartment room like this, you will need more than just the floor, walls, doors, windows, and ceiling. You also have to specify the locations of power switches and floor drains. If the floor drains aren't captured in the scan, you need to measure them manually. But the information we get from the scan is almost complete, far beyond what traditional survey methods can provide. You will notice that LiDAR scanners with a 25-degree leaning angle on the sensors captures more of the ceiling than the floor. The ceiling has almost no blind spot where the floor shows quite a few. Now that the ceiling panels are finished, I'm going to union them together into a single entity. BricsCAD also comes with a model library. I'll drop a toilet into this bathroom. There aren't as many preloaded models as in SketchUp or Revit, but at least I don't have to build it from scratch. Most of my customers don't ask me to position toilets, sinks, or furniture. What they usually want are the floor drain locations and the overhead pipes. Now the 3D apartment model is complete. If you have worked with CAD before, it shouldn't take more than 2 hours to build. Next, I show you how to generate 2D drawings from the 3D model in BricsCAD. In the Annotation tab, click on Base View. It will automatically switch you to paper space where you can place your model in the required projection. In paper space, you can create section views, additional projection views, or detailed views. As you can see, I can generate multiple section drawings in less than a minute. 2D drawing generation in BricsCAD isn't as advanced as in Autodesk Inventor. It's most like an improved version of AutoCAD with automated 2D generation built in. All the annotation tools are available, but most of my customers don't require dimensions on the drawing. For most projects, floor sections and elevations are all the drawing my customers need. BricsCAD provided me with a demo NFR license so that watermark will appear when I print. Yours will look different. You can classify solid bodies using the automatic Bimify command, or you can classify them manually. With the BIM version, you can export files in Revit RVT format or in IFC, the new industry standard for BIM. Okay, I hope you have picked up something from this video. Just follow my workflow and try modeling it yourself. You will learn faster than with a step-by-step tutorial. Thanks for watching. I'll see you in the next video.